Alright, so welcome back. Here's our next episode of Smack101. This time we're covering tips, tools, and basic setup. Hopefully you enjoyed our first episode. We got to explain some different sizes to you, showed you the very basics of flying. Now we've got a few more basics that we got to go through before we can actually fly. Actually, we're going to be flying in our next episode, in episode number 3. But in this one, there's as many important things that you've got to learn here before you can actually fly. So what we do this time is I do a nice detailed overview of all the parts for both an electric and a nitro model. We go over the head, the tail, the main frame, once again for both nitro and electric, so you can understand the differences and what everything does. Then I'm going to walk you through some basic tools and some different accessories that you may need to make your experience a little bit better and hopefully help you out there a little bit. Then I'm going to walk you through some basic setup tips, how that differs from what we do as 3D guys, and lastly explain the importance of training gear and how that's used on your model to make you fly a little bit safer for your first time out. So that being said, sit back and enjoy. Okay, here I'm going to give you a basic overview of all the components on both a nitro and an electric helicopter. First, we're going to start with the rotor head. As you can see here are the blade grips, and the head block is in the center. And we have each of our blades attached to the side. These blades are, this is a 90 size helicopter. These are 690 millimeters. For a 600, it's a 600. Anywhere down to like a T-Rex 450, for instance, flies 325 millimeters. So as you can see are our blade grips, and holding the blade grips onto the to the head block is a spindle shaft in the middle. This spindle shaft, for instance, is 10 millimeters thick, so it's a very big shaft, very strong. You've got the blade grips rotating, and you've got a lot of force pulling out as well. So therefore you use rotational bearings and thrust bearings in the head block. This you'll all see once you build your first helicopter. Next we have the flybar cage with all the mixing arms. This goes out to the flybar paddle. What the flybar does is it acts as a gyroscopic effect on the helicopter, and the gyroscopic effect helps it both it helps for stability, and it helps for also quickness and speed as well. Without the flybar on there, the helicopter would be kind of a dog. It wouldn't really be too much fun to fly around. So the flybar mainly acts for stability in the wind, but also when it's time to give commands, it actually helps speed up the model. Next we move down to the washout base. As you can see here are the washout arms in the central hub, as this is connected to your swash plate. And your swash plate is the thing that actually takes the servo movements and moves all of these up to the head. So there's a lot going on here when it's spinning. As you can see in the videos, there's just, looks like pure chaos going on. But everything is perfectly timed together, and this is all required to make your helicopter fly straight and level. Now it's time to walk you through the main frame. Now the main frame of the helicopter, this is the Nitro helicopter, so you can see there's lots of components on here, and I want to explain each one to you. First we'll start with the largest one. Here's the fuel tank. The fuel tank obviously just holds your fuel and delivers it to this. This is your motor. This, for instance, is a OS 91. This is a 90 size model, so it uses the 700 size, it uses a 90 size motor. For 600 size, you're going to use a 50 size motor. And then for like a Raptor 30, for instance, with the old 550 millimeter blades, they use a 30 size. So here we have our needles as well. On the top is our mid-range needle, and on the bottom is our high-end needle. And this is what we tune in order to make the motor run richer or leaner, depending on its performance. As we walk our way around, you can see our tail servo right here. This goes to the push rod, which goes to the tail boom and gives the tail rotor its commands, whatever we want it to do. As we zoom back here, you can see two of our cyclic servos. As these work together with the one on the other side, all these three work through the bell cranks and then up to the swash plate, and gives the movements from your fingers to the actual rotor head right here. As we come around on top, you can see the start shaft coupler. This is where you'll put your starter hit the button and it'll spin the motor. Your start shaft goes through the clutch. As you can see in here is the clutch bell with the pinion. Through it you can see the clutch. The clutch is a centrifugal clutch, meaning as you spool up and it engages, this is what drives your main gear right here. This is a very large main gear. The main gear is what takes the power from your motor, drives it, and spins your main shaft of the helicopter, which is the biggest shaft on the helicopter, and it gives it all the power and spins the rotor head. Right below we have the tail drive, which will spin the torque tube, as I'll show you in a little bit. Now we're going to go to the other side. So as we move on to the other side of the helicopter, the first thing we'll see is our third servo. This is our third servo involved in making the swash plate move. Now this helicopter, the T-Rex series, uses a system called CCPM, which takes care of collective and your cyclic, involving all three servos together. The other way around this is something like the Raptors use, which is called, we just call it like mechanical CCPM, to where you'll have one servo doing just the pitch function, one doing aileron, and one doing elevator. The T-Rex with the CCPM uses all three servos to take care of all three of these purposes. And it has some inherent features to it. The CCPM is very, very strong and can also be very precise. Since it uses three servos, you get a lot more strength coming in here. And it allows you to use faster servos with less torque. So, you know, it's got that going for it. The only problem with this CCPM is it sometimes has what we call interactions, where you have to go into your computer radio and eliminate these. This is what we show you in some of our setup episodes. So as we come around here, we have a bell crank, and the bell crank is used to mechanically transmit the torque from right here straight up to our swash plate. So as we move around, we see the other side of the fuel tank along with our motor, and this is the throttle arm going to the throttle servo. The throttle servo simply opens and closes the throttle barrel. Lastly, we have the mufflers. You can see the mufflers attached to the motor, and it's quite a long piece of aluminum here. The muffler just pretty much adds power and enables our motors to be much quieter and enables for us to tune them easier. These have a very detailed baffled system and just has many intricate pieces in here. You know, you can't just toss any muffler on. Usually they're made by the manufacturers precisely for a certain motor. So as we work our way back from the main frame to the tail, you can see the long tail boom. I'm sure you've seen the look of a tail boom before. Now there's two ways to transmit the power from the main frame of the helicopter back to the tail rotor. This model uses a torque tube. Now the torque tube, what it has is it has a separate gear that spins underneath here, and then that transmits the power to these two gears right here, turns it horizontally, and then you have like an arrow shaft that spins this way, spins all the way back and goes to our teeth in the gearbox. The other way to achieve this is a belt. It's kind of like your timing belt on your motor of your automobile. It just uses a belt, and then back here uses a pulley. It's a very simple, cheap and lightweight system. The torque tube just gives a little bit more performance because you seem to have less drag, and guys just seem to like them better. They're pretty smooth and no big deals. So we've got our gears here, which takes the power from the torque tube and outputs it to the output shaft, as you can see here, as we also have our slider mechanism. Now the slider mechanism gives pitch to the tail rotor blades just like your main blade has. So it's allowed to spin and give pitch at the same time. Lastly, you can see our tail blades. These are carbon fiber. These in particular are 115 millimeters. This is what we use on the T-Rex. This is given, your slider mechanism is given an input from your tail rotor servo, which I showed you earlier. And finally, the last thing that I want to show you is the receiver and some of the electronics. So here we have the receiver. This is an 8-channel receiver. We've got all 8 plugs going into it. Then this is what distributes all your power and your signals to the rest of the helicopter. Next we have a regulator. This is called the reactor. As you can see here, it has a heat sink, and this just simply takes my battery voltage, which is 7.4, and then it reduces it to 5 volts for the receiver, but it also gives me a little bit more voltage to the servos. So it just helps as a regulator. Some of the Spectrum radios, such as the DX7 with the AER7100R, does not require a regulator. Next we have our gyro. This is called the GY520 from Futaba. The gyro simply compensates for any yaw movement left and right in your rudder. This has what we call heading hold. What heading hold allows you to do is to keep your tail rotor pointed at the same vector throughout the whole flight until you tell it to change. So this is what enables us to fly sideways and backwards with incredible ease. Next, as we come around here, we can see just the receiver battery. This is just a 2-cell lithium battery. So with the 2-cell battery and my regulator going to the receiver, I'm able to power up everything. You can also use a NiCad battery or a NIM battery. It's really just personal preference. To tell you the truth, as a beginner, I would just use a nice big NiCad. Use a 2400 milliamp 4-cell NiCad, and that'll let you fly for a few flights. Biggest thing here, always check your voltage. You always want to make sure you have a nice voltage here. Very last thing I want to point out to you is the governor and my switch glow. This is the governor right here in the blue. The governor tells your rotor head to maintain the RPM, the same RPM throughout the entire flight. So we mount that up here along with the switch glow. The switch glow takes place of a glow driver. It's an onboard glow driver. You simply flick a switch. It gives power down here to the glow plug on the motor, and you can start your helicopter right up. And here's our switch. Alright, lastly I'm going to show you the difference in our Nitro model and our electric model. So here I have my Furion 600 from Miniature Aircraft. So the biggest thing is this big battery here. We've got two 5S batteries in series giving us a 10-cell setup. Now as you can see here, there's no nitro motor, there's no muffler. So this weight is usually compensated for by the weight of the batteries. The weight of the batteries are usually more than half the helicopter. Here again we have the same receiver pack. It's the same thing. I use the same receiver pack and regulator to power the helicopter. As you can see here, once again, we still have a main gear, but the main gear this time is spun not by a clutch with a nitro motor, but by our big electric motor here. Once again, this uses 10 cells, so this is around 40 volts, and draws as many as up to 100 amps. Once again, from the swash plate up, we pretty much have the same exact setup. The main difference is some of the components here. So as we flip around, I can show you the regulator. Once again, it's the same thing. We have the same receiver sort of setup, but lastly what we have here is the speed controller. The speed controller is what takes your inputs from your receiver, uses the power from your throttle, uses the power from your battery and delivers this to the motor. This is a 80 amp speed controller, for instance, from Castle Creations. These seem to work pretty well for us. So this is your basic overview of your electric model. Okay, now I'm going to walk you through some of the tools that we use and some of the different accessories that we use. A few of the different things that I may have mentioned last time. These are some things that I've kind of learned throughout the years, a few things I learned later than others, and I wish I would have known at least a few of these things before I started the hobby, so maybe this will help you out. So we're going to start first with the Nitro model. So last time I mentioned we're going to need fuel and a fuel pump. So here you can see we've got fuel and the fuel pump right here. This is just a large battery on there to make the fuel pump go. You can get a hand crank or electric. Either one is fine. They both have their pros and cons, but just choose something that works well for you. Next we have the starter. This one's just made by a line. It's kind of nice. It's small. You just hit the button, spins the shaft, and it starts your motor. Simple as that. Next we have a glow driver. I don't have one anymore because I use the onboard switch glow, but this is what your glow driver will look like. It's just a 1.5 volt battery, just a AA or D size battery, and then it clips onto the front of your glow plug, and then with that small voltage it heats up, and then when you hit your starter, boom, starts right up. So that's your glow plug. So we have our starter. Next I'm going to show you a few things that you may need for electric helicopters. So the first is a charger. This is a nice Hyperion one. It's able to charge 2 batteries at one time. Get yourself a nice charger that you can grow with. I don't fly electrics too much, but I'm glad that I've got this because I can charge receiver batteries with it, anything from 2 cell all the way up to 6 cell. So I can charge a big 90 size helicopter with this charger right here. It's very nice. The next is the power supply. This guy is just awesome. I bought this at Radio Shack a few years ago. This is a 25 amp power supply. Plug it into the wall and then it outputs in DC, so you don't have to have a big battery, or your car battery. You don't have to take your batteries out to your car in order to charge. You can charge right at home. Power supply, very useful. Next are just a few tools that we also use. I really recommend like a nice voltmeter or something. A lot of times guys will just solder their connectors to the end right here. Take this to the field with you. Make sure you're putting in good batteries. Always make sure you monitor your batteries. If you're using a NiCad battery for your receiver pack, for instance, you want to make sure it's above that 5-volt area. A lot of times now we use lithium batteries, so for a receiver pack you would never fly below 7 volts. And then you can also check your flight packs to make sure that indeed you charge them. Next are just some tools that we use. A lot of times in the kits, the manufacturers will provide you with L-wrenches, but we really recommend the hex drivers such as these. The biggest sizes are 1.5, 2, 2.5, and 3 millimeters, you can see here in the hex wrench. I would highly suggest investing in some of these. These are made by Thorpe. They're like 13 bucks a piece, but well worth it. You just won't break it. Building a kit with the L-wrenches is no fun. And then we've got like a Phillips head screwdriver, and you can have a flathead screwdriver. Just nice tools make all the difference. For you Nitro guys, a glow driver is good. I believe it's a 5/16 size. That'll work. Enough sped. You need to take your glow plug out if it fries out, so make sure you got one of these guys. Next is our blue Loctite and our green Loctite. Bert and I really don't use red Loctite. We prefer green. Green kind of wicks in. It's a little bit stronger. Blue Loctite is what we use on anything metal to metal. So if you're putting a metal screw into a metal fastener of some sort, like a metal stud in the frame, you'd always put blue Loctite on there. Now for things that need a little bit more strength or that tend to come loose, we use the green Loctite, just a little bit. There's also red Loctite. You can red Loctite a bolt in there, but in my experience, it just holds too strong, and then when it's time to take it apart, I can't really pull it apart. So I use blue and green. And lastly are a few other things. This is just double-sided tape that you can get from Walmart. This is made by 3M. It peels off. This stuff is great. It sticks anything to anything. Seriously, anything. So you can use it to mount your receivers into your frames, or your battery onto your fuel pump, for instance, anything. Next, what we use a lot of is Velcro. Once again, this comes from Walmart or Lowe's, or sometimes it comes with helicopter kits. This is really good for wrapping wires together. A lot of times people will zip tie a wire together, and the zip tie will eat through the wire. So always make sure you use Velcro. It's nice and soft. You can peel it right off. It's not too heavy. Works well. And last but not least, I use goop. Anytime I have a receiver, a wire plugging into receiver, or a extension, for instance, I always put a little bit of goop on there, even right on the receiver, as you may have seen earlier in the episode. I've had way too many plugs come unplugged in flight, causing a crash, and there's just no reason for that. I mean, there's no reason. So what I do is, once I plug all the plugs into the receiver, I'll take a thin bead of goop and just put it on the outside. When it's time to pull it out, you just pull your plug out, pull the goop off. That leaves no residue, holds no harm, but it holds it in there. So this is just that extra bit of security that you can use in your model to make sure it works. So these are just a few tools and different accessories that we use. Okay, the next thing that I want to talk to you guys about, that I mentioned briefly last episode, is the electronics. We're going to dive in a little bit deeper right here. So electronics is the main function, the main way to interface in between you and the helicopter. The helicopter is a very mechanical thing. You have many linkages, you have many moving parts, but it takes the electronics in order for you to tell the helicopter what you want it to do. So it's pretty important that you have some good gear in there. Beginning with the transmitter. Now there's 2.4 gigahertz available. In the past, we used to use 72 megahertz in the US, or overseas they use 36 megahertz and some different other frequencies. The 2.4 gigahertz transmitters and receivers have just become a lifesaver. So when it's time to buy your transmitter, make sure you look into that technology. You can just turn it on. You don't have to clear channel with anyone. There's no lockout problems. There's nothing like that. So that's really something you should take a look into. The next is the receiver. You want to make sure that you buy like a nice receiver. I don't know if they offer any sort of aftermarket receivers or anything, but either buy, if it's a Futaba receiver, buy Futaba transmitter, buy a Futaba receiver. If it's JR, buy JR. You know, don't mix and match. It's probably not a good idea. The next thing you want to take a look into and really invest in a good one is a gyro. As I mentioned last time, like a GY401 or a 520 or a Spartan gyro or the JR, I believe it's the 770 series, something in there. You really want to invest in a good one because it'll make your experience that much better. For starting out today, there's no reason not to have a heading hold gyro, which, as I said last time, if you point your tail this direction, it'll stay there until you tell it to move. So really invest in a good one. That's something not to go cheap on. The next thing to take a look at is a governor. A governor is a very simple thing. All it is you tell the helicopter what head speed you want the main rotors to stay at the whole time. It has control over your throttle servo, and it does whatever it has to do to the throttle servo to open the barrel and close it to make the head speed stay the same the whole time. So that means that you won't get any overspeeding. Now, a governor now you can buy anywhere from probably $60 up to $150 maybe. You should really invest in one of them. Even if you're just starting out, it's probably not a bad idea. If you're starting to loop and roll, but you should probably take a look into a governor. Some of these guys are even building governors and gyros into their receivers and everything, kind of like the Mikado V-bar unit or Curtis's Total G unit, which is coming in soon. Everything's starting to be built into one. So just kind of take a look at that. So these things you really don't want to go cheap on, and it's probably a good idea to make the investment right off the bat so you're not upgrading later. Alright, so here I'm just going to walk you through a very brief setup here of the helicopter. I'm not going to go through any of the setup tips here because Bert and I dedicated an entire episode to setups in episode number 3. But I just want to show you a few things that you want to keep in mind as a beginner. So when you get your first helicopter, I highly suggest, once again, take a look at our episode 3. We'll walk you through all the setups, what everything does, how to check your pitch, and everything like that, and everything in those lines. But I just want to tell you a few things that we mentioned in the setup episode as they differ from 3D to a beginner. So as a beginner, when it's time to finally check your collective pitch, so your collective is up and down like this, you really want to make sure you don't have too much in here. The same with your cyclic pitch, both in your elevator this way and your aileron sideways. I would really recommend as a beginner that as the collective up and down, you have 10 degrees and 10 degrees on the bottom. You set it up completely linear like this, and then in the center you want to roughly be around 0 degrees as you set it up. Then when it's time to check your cyclic pitch, when you do your when you put your pitch gauge on, you really want to be around 7 degrees. This is a good beginner setup. Now, with the collective, 10 degrees negative pitch is kind of a lot. That means that when you give the stick full down, it's going to go down very fast. So what we do is I go into my pitch curve right here, as you can see, my pitch curve, and what I can do is I can take my bottom point and I move it up. So right here it would mean that this negative is no longer 10 degrees, and we'd move it up. Usually we start guys out with around -4 degrees, and -4 is enough for them to still bring their stick down, but it's enough to where they're not giving full stick and it won't drive it right into the ground. So this means that when it's time to hover, you're going to be hovering more around half stick, whereas with 3D we hover around 3/4 stick. This is about where it is. So this is the only difference that I'd really recommend that you really pay attention to as you're setting up your first helicopter. Other than that, just go by our instructions that we gave in episode 3, and it's the same thing. Alright, now that we've taken care of everything here on the ground, there's one more thing that you want to do before you fire up your first model. So last thing of advice that we want to give you before you first take off is to invest in some training gear. You'll think to yourself, training gear, what's that? Training gear looks like this. Training gear is basically just 4 sticks with some sort of a wiffle ball on the end. They're all attached to a center point here, and then your helicopter actually sits here, and you usually rubber band the skids around each leg of the training gear. So when you're done, it'll look something kind of like this. Now what the training gear does is it gives you a lot more leeway and a lot more flexibility and room for error when you're first taking off. I can almost guarantee, like I did, the first time you take off, you're going to be sideways and kind of all over the place, and it'll allow you to kind of tip over a little bit more than usual. The landing skids only gives you a very small area to land on without tipping over. So the training gear, what we do is we go out, and you can either build these or you can buy them. and it just gives you a lot more room for error. So I'd highly recommend some of this. So we took a little trip to Lowe's and Walmart, and now you can see how we made our training gear. All right, so here we need to figure out what kind of dowels we got here. We're at the hardware store. This is some 5/16. That's not gonna work. What is this? 1/2 inch. Ain't bad. That's not bad. That's not bad. Ah, here we go. Oh, that's nice right there. All right, so we're gonna go with the 1/2 inch by 48. It's good stuff. So we need two of these. Now we get to go to Walmart and find some wiffle balls. All right, so here we're at Walmart, possibly the world's greatest invention to man ever. There's some wiffle balls here. We even have colors, blue, ooh, green and yellow at the same time. White. We'll go with white. All right, so thank you guys for watching our second episode of Smack101. Hopefully this was helpful for you guys. Maybe you learned a little bit more about the ground station and everything that's involved with that. Next time we're flying. Next time we're gonna fire up both a nitro and an electric. We're gonna show you the very first things that you do when you first take off your model. It'll kind of build on the things that we did in the setups episode, number 3, and it'll kind of be a new sort of thing. I'm gonna show you your very first things that you wanna do as a beginner. Certain things to make sure that you don't crash your first time out. So that being said, thanks for watching. We'll see you next time. So here we have our training gear for 90s high. Sorry, kid. Could do many things with a stick. I'm also gonna get this for Bert.